Welcome to the Deep Dive, where we take a laser focus on the most specific technological advancements of today and use them as lenses to examine, well, some of the grandest, most complex questions facing humanity.
Today we are taking you right inside a next-generation factory floor in China. We're looking at sub-millimeter dexterity and 247 robotic autonomy.
And we're using that very technical reality to understand our place in geological history, specifically the Anthropocene, and the philosophy behind what happens when labor becomes obsolete.
It sounds like a huge leap, I know.
Yeah.
But the sources we have show a very direct line between a robot changing its own battery and, say, Herbert Marcuse's critique of the affluent society.
So our mission is to unpack this quiet but incredibly swift revolution happening in advanced manufacturing right now.
Exactly. I mean, we need to stop focusing on those viral videos of, acrobatic prototypes doing backflips.
Right. Fun to watch, but not the reality on the ground.
Not anymore. Our sources confirm we are no longer talking about potential. We're detailing the current mass deployment of a new class of industrial humanoid robots. They're already clocking in for real, continuous 2047 factory jobs.
And this signals a new stage of automation that is already contributing to job shockwaves and, I think, forcing some profound societal reflection.
That's too.
So before we can appreciate those implications, we need to clarify the foundation.
Sure.
When we talk about these machines, what's the precise technical distinction between an AI and a humanoid in this context?
It's a great question. We should probably clarify the terminology for you, starting with the broadest category, embodied AI.
Okay.
This isn't just a fancy phrase. Embodied AI is any AI-powered hardware system that can perceive, interpret, and then act upon the physical world.
So it takes in things like sight, sound, even touch.
Multimodal inputs, exactly. And it makes complex, autonomous decisions, executes physical actions, and this is the key, it learns from those interactions.
So if I have a smart factory arm that just repeats one motion, that's just automation. But if it can adapt when a part arrives, say, slightly out of position, that's embodied AI.
Precisely. The definition is all about its capabilities. High autonomy, adaptability, and the ability to handle diverse tasks in a dynamic environment. It can be a drone, an autonomous vehicle, you name it.
Which brings us to the more visually striking part of this discussion, the humanoid robots.
And humanoid robots are defined primarily by their form, their human-like form, 2 arms, 2 legs, a torso, all designed to navigate environments that are, already built for people.
But they only become effective embodied AI systems when they're layered with all the sophisticated sensors and, crucially, those advanced multimodal AI models.
That's it. It really feels like the software stack is the breakthrough here, almost overriding the physical chassis.
It's the brain, not just the body.
Absolutely. The engine for this new wave of industrial autonomy is large language models, LLMs. We think of them for writing or coding, but here they act as the complex reasoning and linguistic backbone.
And you add on the vision and action module.
Exactly. And that allows the system to interpret high-level natural language goals.
Yeah.
So a foreman can just tell the system, prep all materials for the next 3 assembly stations, and the AI autonomously breaks that down into thousands of specific physical actions.
That transition from a high-level sentence to real-world sub-millimeter action, that's the holy grail, isn't it?
It is. And this brings us directly to the most significant news in our sources about mass deployment.
Right.
That milestone belongs to China's UBTech Robotics. They announced the mass production and delivery of their first batch of full-sized industrial humanoid robots, the Walker S2.
And this is being called the first verifiable large-scale delivery of humanoids designed to move and operate like humans for practical, continuous industrial jobs.
And we have specific examples of them already deployed, right?
We do. In March of 2025, a coordinated team of these UBTech robots was deployed at Zeekr, a leading electric vehicle manufacturer.
And they were powered by a multimodal reasoning model based on DeepSeek R1.
Wait, DeepSeek R1. We hear model names thrown around all the time, but why is mentioning that specific reasoning model important? What does it let them do that a standard purpose-built industrial AI couldn't?
That's a crucial question. DeepSeek R1 is a foundational model. It's built for multimodal inputs from the ground up. A standard industrial AI is often brittle. It's great at one repetitive task, but then the environment changes and it's lost.
I see.
DeepSeek R1, acting as the brain, allows these robots to do what you might call non-linear thinking. It can reason about spatial relationships, infer context from incomplete visual data, and recover autonomously from unexpected events.
So they can use human tools, manage logistics, perform quality checks, all in the same workflow.
Exactly. That versatility means they aren't just screwing in a bolt, they are managing a sequence of complex tasks, which is what human factory labor typically handles.
And the market is clearly recognizing this capability.
Oh, absolutely. UB Tech secured 800 million yuan in orders this year. That's roughly 113 million US dollars. The demand is centered on stability, precision, and endurance.
And the customers are the big players.
The biggest. Major automakers like BYD, Geely Auto, FAW, Volkswagen, and then logistics behemoths like Foxconn. These are industries where tiny efficiency gains at scale translate into, well, massive financial benefits.
And the scale they're projecting is just staggering. UB Tech is planning to ship 500 walkers by the end of next year.
But their long-term goal is 10,000 units annually by 2027. This isn't just a corporate venture, is it?
Far from it. This mass production effort aligns perfectly with China's national strategy to achieve leadership in embodied AI.
They're deliberately trying to transition the breakthroughs of generative AI, the DeepSeek R1s of the world, from the digital realm directly into the real economy, sectors that produce tangible goods.
It's about long-term industrial competitiveness.
For sure. And we should probably talk about the specific technical feature that underpins that competitive advantage, because it is what enables the robot to truly be an uninterrupted worker.
Let's do it.
This is the real engineering marvel. It's what allows for scaling up continuous operations. The Walker S2 is the world's first humanoid robot capable of autonomously changing its own batteries. It has a dual battery system and hot swap capability.
The machine takes care of its own power needs. That is fascinating.
It's the ultimate self-sufficiency. The robot autonomously navigates to a power station, uses its coordinated dual arms to remove the depleted pack, and inserts a fresh one. All within minutes. No human intervention.
So that autonomous power management just eliminates downtime.
Completely. It allows the robot to work continuously 24 hours a day, 7 days a week. It matches the flexibility of a human worker, but utterly exceeds human endurance.
Okay, but I have a question. If the goal is just factory work, isn't designing a highly complex bipedal humanoid, I don't know, less efficient, more costly than just using a purpose-built industrial arm fixed to the ceiling? Are we prioritizing form over function here?
That's a sharp critique, and it's one robotics engineers face all the time. But the defense of the humanoid form isn't purely aesthetic, it's infrastructural.
Infrastructural.
Think about it. Factories today are built for human dimensions. Human door sizes, human ladders, human-sized controls. A general-purpose humanoid can slot right into that existing infrastructure and start working immediately.
So you don't need a multi-million-dollar factory retrofit.
Exactly. It solves the last-mile problem of automation.
That makes perfect sense. It's about seamless integration into human-centric spaces. And the capability is there. We noted the precision due to its 52 degrees of freedom across its body.
Right. That provides the dexterity needed for that sub-millimeter precision. It's built light but strong aerospace-grade aluminum, carbon fiber reinforced polymer.
So it's light, only 43 kilograms.
But it can still carry up to 15 kilograms of payload. That's enough to move tools, heavy components, and manage logistics effectively.
And they coordinate them using swarm intelligence.
Yes, the proprietary BrainNet 2.0 system. It enables swarm-like multi-robot collaboration. So you aren't just deploying one robot for one job. You're optimizing the entire factory workflow by coordinating fleets of tireless machines.
And that key detail, that continuous, never-pausing ability, immediately sends a chill through the labor market, doesn't it? This rush toward total automation is already translating into job shockwaves in the US and Europe, according to our sources.
That's the painful reality that runs parallel to this technological achievement. But we're seeing major corporations leverage these AI and automation breakthroughs to justify massive workforce reductions, HP, for example.
They're trimming up to 6,000 roles by 2028.
And they're explicitly stating the funds saved will be channeled right back into automation projects.
And we've seen similar impacts in service industries, which were, previously thought to be safer than manufacturing.
Absolutely. The insurance giant Allianz is proposing layoffs of 1,500 to 1,800 people in their call centers.
Nice.
The reason? AI is replacing those manual, repetitive customer service processes. This inflection point is moving much faster than most analysts predicted.
It's a jarring contrast. Technical utopia on the factory floor versus structural obsolescence for human workers. Let's use that core concept, the relentless, tireless 247 pursuit of production as the bridge to the grandest scale of all, planetary history. How does the rise of machine labor connect to the Anthropocene?
Well, the relentless productivity of a machine like the Walker S2 fundamentally embodies the industrial mindset that began to dominate the planet centuries ago. If you look back to the first Industrial Revolution around 1750 to 1840,
We shifted from human and animal muscle to machinery, steam engines, spinning jennies.
right, it brought prosperity, sure, but our sources remind us it also initiated massive environmental depletion and crippling wealth disparity.
And the concept of the Anthropocene argues that the impact of that industrial mindset is now etched into the very crust of the Earth.
Precisely. The core idea is that human impact on the global environment, through land transformation, the atmosphere, the oceans, is now the dominant cause of change. We've left the Holocene. Our activity will leave traces in the geological record for millions of years.
What are the most powerful markers of this change right now?
There are several. One is the global nitrogen cycle. Human actions have fundamentally altered it, mainly because of the Haber-Bosch process, which lets us create synthetic fertilizer.
Right. So an early technological leap that solved one huge human problem feeding billions created a massive planetary one.
Exactly. And we have carbon. Human activities have released immense amounts of carbon since 1750, increasing atmospheric CO2 to levels not seen for at least 800,000 years. It's a massive permanent signature.
There's a fascinating complex debate about when the Anthropocene officially began, but it seems like the defining factor is always some kind of technological or demographic shift.
It is. Some scientists argue for the Neolithic Revolution, when farming began to reshape landscapes. Others propose the Orbis GSSP, which marks the collision of Old and New World peoples and the resulting, well, homogenization of global biotas.
Speaking of homogenization, I recall the sources mentioning an alternative term for this epoch.
That's the Homogenocene. It's an alternative term that specifically focuses on the profound mixing of life on Earth, the global homogenization of biotas through the introduction of alien or invasive species. It emphasizes that human activity has fundamentally erased the ancient distinctions between ecosystems.
But the marker that relates most closely to the Walker S2 and its tireless production, that turbocharging of the industrial mind, is the most recent one.
That's the Great Acceleration, anchored around 1950. This is marked by an extraordinary spike in human energy consumption, population growth, and critically, the creation of human-made materials,
Concrete, plastics, metal.
which according to some studies, now collectively exceed the total living biomass of Earth. The Walker S2's mass deployment isn't just factory automation. It's the technical means to sustain and drastically accelerate this era.
And if we turbocharge production and consumption, we have to look at the philosophical implications of a society drowning in goods. This is where Herbert Marcuse comes in with his critique of advanced industrial society.
This is the ultimate connection. The elimination of factory labor leads directly to the question of human purpose. Marcuse argued that modern industrial society, whether it was capitalist or socialist, had achieved the material potential to solve the problem of scarcity, to essentially pacify human existence through technology.
They could have chosen liberation and leisure, but they chose relentless production instead. Why?
Because the system needed to survive. The specter haunting this powerful industrial society was the obsolescence of full-time alienation. If machines could produce everything, why would the human worker still have to toil?
So the system had to artificially maintain competition, insecurity, and violence to justify itself.
And it does that by creating and enforcing false needs. This is the core of his critique.
Okay.
Modern society, according to Marcuse, is ruthlessly efficient at delivering the goods, but that efficiency represses the deeper human need for liberation. It sustains its own destructive power by ensuring people confuse manufactured desires with genuine human needs.
And false needs are things like the need for production and consumption of waste, or the need to engage in stupefying work even when it's technically unnecessary.
Exactly. In the 21st century, it works by channeling all satisfaction into what he called compensatory rewards. If your job is meaningless, society offers consumption-based fixes, the newest gadget, directed leisure like high-intensity tourism, escapism through entertainment.
And these false needs are a mechanism of social control because they divert our energy away from critical reflection.
They do. So the rise of the 247 robot worker, which makes the technical necessity of human toil truly obsolete, forces a crisis in this system. Marcuse defined radical change as transforming both social institutions and our individual psychology, replacing those compensatory needs with what he called emancipatory needs.
Right. And he laid out 4 of them.
He did. First, the need for drastically reducing socially necessary alienated labor and replacing it with creative work. Second, the need for autonomous free, not directed leisure, but time truly free of productive expectation.
Third was an end to social role-playing, where authenticity replaces performance. And that final, crucial need that seems so elusive in our always-on world.
The fourth is the need for receptivity, for tranquility, and for what he beautifully called abounding joy, replacing the constant noise and pressure of production and consumption.
And he tied all this back to ecology. He argued that genuine ecology requires a fundamental transformation of our inner nature.
This is a powerful synthesis. We've moved from a 43-kilogram robot swapping its own battery to achieve 247 uptime, all the way to the grandest debates about human geological impact and the philosophical potential for liberation.
And that connection is unavoidable now, isn't it? Marcuse warned that society tends toward a comfortable, smooth, reasonable, democratic unfreedom by constantly satisfying these manufactured needs.
And with AI and robots like the Walker S2 making vast segments of alienated labor truly and technically unnecessary, the contradiction he outlined just reaches a fever pitch. The system can produce everything, but does it allow us to truly live?
So, here's the provocative thought we leave you with. If industrial humanoids, such as the Walker S2, successfully and permanently solve the fundamental economic problem of manufacturing bottlenecks through tireless, 247 productivity, permanently freeing vast segments of the human population from socially necessary alienated labor, what new compensatory structures will advanced industrial society deploy to prevent the widespread emergence of Marcuse's emancipatory needs for tranquility, creative work, and autonomous free time? Does the technical ability to achieve utopia simply create a new, deeper dimension of control where the new battleground is not labor but desire itself?